At least I did.
Yes. So Maiken, we purposely have this pace a little bit slow. So I'd apologize if it's boring for some people, but it's very important, Maiken, that we have these concepts grasped properly in order to understand the rest. So then in a HPC system, we are talking about these shared resources. Earlier, I saw this comment about that someone managed to occupy the whole system, so it was disturbing others. In a system where thousands of users are logged in, we should have a more proper way to manage this. So the examples that we are going to use is with a restaurant, and it is very important that you don't take this literally, the explanation, but try to compare what we are going to convey. So Maiken, again, to some discussions we had about 6 months ago, you said that you have been in this popular restaurant that you had to have pre-booking. How did that go? Did you manage to get a table?
Yes, but I had to get an allocation. So
Okay.
they didn't just let me in. They had to set up a time for me, and then I had to come at that time.
Okay, so you're working on HPC systems for too long. So did you call the restaurant and ask for an allocation? How did that go?
Yes, I did exactly that.
Okay. So why do you think that you needed to make that reservation, if you call it more in a more restaurant friendly way? Why do you think that was needed?
Well, it's basically because there are a limited number of chairs and tables and cooks and food and everything. So in order to actually be seated, there needs to be an organization of the line of people. And yes. So that's easy to understand.
Easy to understand. So let's say if you don't make a reservation, and imagine that there's a bar or a restaurant that they accept people as they come as well, you might see some queues outside. Maybe while you are sitting inside this popular restaurant enjoying your meal, there might be people waiting outside who did not make a reservation but waiting in the queue. How is your feeling about waiting in queues? Have you been in queues? Do you like them?
No, that's rather boring, but necessary sometimes.
Why do you think it's necessary?
Well, otherwise you might kind of think of people running in and just pushing you out of your chair, for example, or things like that. Not such nice situations.
No, so it is to avoid pure chaos if you don't have some management. So we could think of as our shared HPC resources as a restaurant that we are there to serve people. The restaurant is for the customers. So without the customers, there's no point having a restaurant. But you will see some queue and some sort of housekeeping and some sort of management when it comes to how you use the system. So overall, all the users can have a better experience. So here we have this blue person here, which is inside this yellow highlighter box. So we have such a person who's managing these things. So this person would have a proper idea of how much resources we have inside, how many, in this case, some tables, but on our HPC systems, compute nodes, how many of them are free, how many of them can be allocated, and he also decides it also decides who comes first, who could go in first and how long they can stay, and that sort of things. But Maiken, because humans could be sort of biased in that case, we don't want any people letting in friends. So this is fortunately a piece of software. So do you have any experience with this piece of software, and do you know about this? Yeah.
Yes. So, well, you already showed commands from this software with sinfo and stuff like that. So there's several type of softwares, and we'll be learning about Slurm.
Correct.
In this
so
course.
This is Slurm. So we call it a queue manager, the piece of software that manages queue. And whatever you do on our systems, when you want to run a job, you'll be doing your interaction with Slurm. So you will pack everything into a file, what you want to process, give it to Slurm. Slurm will do the processing and give it to you. So it's sort of a middleman here, which would not directly relate to this diagram, but we could also use this as an example. So once you're inside the cluster, you will have idle nodes. Idle means they are ready to accept jobs. You are free. You could go. So this person would, the Slurm would send anybody who's in the queue to this table without any hesitation. So they will go there. So when they go inside, the people who go inside should tell Slurm, this queue manager, how long they are going to dine. Why do you think it's important, Maikan, that they tell the queue manager that how long they want to be inside the restaurant?
Well, that's because otherwise it's hard to schedule when the next jobs will be running.
Yes. So he has also the obligation to tell the rest of the queue, how much they have to wait. Then you have these reservations, as you did with your restaurant. So you could make a reservation and then come in and sit, and then you don't have to wait in the queue. So this is when that COVID reservation comes in, Maikan. So we have these shared resources, highly sought after, people, it's always busy, but it's also possible to make reservations in an emergency case or a requirement or in a course like this. Do you see the importance of that, Maikan?
Sorry, what you said?
Do you see the importance of that, the ability to make reservations as well?
Yeah, that's really important, because exactly like especially in the beginning, for example, in the pandemics, the folk, what's it called? The Folkhälsoinstitutet, they needed to do a lot of computations to be able to do predictions about the spread of COVID, and they needed a lot of resources for this. And so with this capability of reserving, resources for a specific task, they could do that without having to wait. So that's important.
So today for the course, we have allocation as well. So when you come to this Slurm manager, when we submit jobs, we will give him some extra information when you go inside. So that extra information is not usually used during a normal job. That extra information is like, a VIP card. So we have this VIP card today. So we're going to give that in addition to other things. When people are inside, when it is occupied, when a computer is doing some processing, it's called busy, or processing, or people are, using it, not processing, maybe some is waiting for the processing, it's busy. Again, you could have idle cores. This is if you think of it, this table as a compute node, that the diagrams on the pictures on the HackMD, one of those. Inside those, you would have multiple cores that could do work at the same time. So maybe some of them are allocated. So this case, you could have a table with you share with strange people. It's possible that when you logged in and when you're running the job, you might see that other people run as well. So we call this a non-exclusive access. You could also ask for exclusive access, which means that you ask for a table. Let's say this table, if you ask, you only need 2 chairs, but you tell the restaurateur that you need the whole table, you will pay for it. So don't let anybody else. If the chairs are free, just leave it. So we call it exclusive access. And the term allocated means the Slurm, the workload manager or the queue manager has already decided somebody's on the way. So although that chair is free, you are not supposed to fit in it. Anything else you want to add to this, Maikan?
No, I think that's quite clear. It's a good example.
Yeah. Yes. So then we go on creating our first job. So we're going to do this from, as I said before, from our Unix experience, we know that we can create directories. So I'm going to clear the screen first, and I'm going to make a directory, which is not here detailed here. That the reason I'm going to make a directory and work inside is that it's easier for me to show you the log files. So you don't have to create a directory, but it's better for the better housekeeping. So I'm going to change into that directory.
So should people try to type along now or just watch?
Yeah, wait a little bit, then you can start. Yes, that's a good point. So just watch what I'm doing. Then I'll give you some hints, and then at the exercise, when you have the exercise, you could try this. So you'll have time for that. So it's better that you follow me, watch me now, and then you do this later. Then I will use the ls command to show you that there are no files here. Then I'm going to use the editor called Nano. I will create the exact file as in the exercise, so there'll be less confusion when it comes to what to type, and it's easier to follow. Nano is the editor we learned yesterday. If you have any other favorite editor, please go and use it during the exercises. But if you don't have a preference, use this one. Inside that file, Michael, you remember you showed this shebang yesterday. My keyboard, yes, yesterday, which means that this is going to be a bash script, a script written in the language called bash. Then I'm going to echo, which would print what I'm saying here with a dash n, which means that don't go to the next line, just remain this line, this script. So if you forget, if you don't know what echo does, Maiken, what was the command that you used to get the manual?
man, man, and then space, and then echo, the command.
Echo. Yes, man command. So we have this file created, very simple script, printing the host name here. So I'm going to use Control W to, sorry, that is search. Control O, hold down the Control key and press the O to save. Hold down the Control key and X to exit. So to make it more obvious, I'm going to use the cat command to see what I'm typed. So this is what I've typed. So usually I use the command hostname, which would print the hostname, but now I have a script to do that. So the script is like this. Then I'm going to make it executable. So in Unix, as yesterday you showed that not all files are executable by default. You have to define it that as executable. I'll show the permissions now. Then I'm going to give it executable permission, and then ls again. And can you see that it turns color as well on my terminal because I color coded it? It's executable. Now, Michael, I'm going to run this on the login node. So which we usually don't run jobs on login node. We can use it for transferring files, compiling smaller applications, etc. But in order, yes, Michael.
Sorry, how do you know that you're running it on the login node and not the compute node?
Yes, so one thing is that we are on this computer called login node here. So which shows us that it's a login node. And the other thing is we are not going to ask that blue guy, if you remember, the slum. We are not going to interact with him. We are going to directly execute it. On Unix, you could execute it with the // format, example, and it will run and it will print this script is running on login one. So now we are trying to think about that paradigm shift that we are talking about. Now we are running as if it was in front of our computer. So we type something, we wait for it, and then we saw the output. So this is on the login node. Big jobs, we don't do that because it's a very small job. We want to test this, we run this. So we could also test things. And if it is a job that takes 2 days, what would you think would happen, Michael? Finish, because this small one is finished quickly. If it's very long, what would you think the outcome would be?
Well, probably you'd close your laptop and the process would stop and it would crash or just stop.
Yes, correct. So then when the network is disrupted, or if you look down, the script would not run. You could take measures, but that's to run it in the background. But it will still not use our supercomputer or the cluster that you're talking about. Then we will try to understand how to send this. So the same thing we did on the compute node, as if it was a remote server. So people who are joining from the machine learning infrastructure from University of Oslo, they usually run it on a server. Now this is the way they do it. So now we're going to see the difference when we're going to interact with the queue manager. So one thing, Michael, that when you need to use this computer is that you have to pay for it. To pay, you need an account, so the bank account. The thing is that you don't pay money for each job, but you pay some credits. So you get some credits when you logged in. So these credits, at some point, somebody has paid. At top level, the Norwegian taxpayers would have paid for it. So these are compute credits. So you have to use it responsibly, although you don't pay money each time. You have to keep in mind that somebody has paid at some point. So we will ask the bank accounts that I have access to, opening up your wallet and see what credit cards we have. I have these accounts. So all of you will not have the identical thing. So you have other projects that might be available, but you should at least see this account, which is the course account, which is that VIP pass. So without this account, you might be not be able to. You are not able to use the VIP pass to run jobs today, but you should at least see that. So I want everybody to log into from and type projects after logging in. Don't worry about this running jobs or the examples or anything that we will do during the exercise. But I want you to check the projects and on the HackMD, give a feedback whether you see this project. So during the exercise, we can be prepared how many of you have or not have accounts. So I'll give you 2 to 3 minutes. Log into from and type the command called projects to see which projects you have access to. If you are doing it on another cluster like Fox, for example, you will see a different way of naming projects, EC- something. That's also okay. But if it's in from, you should see these accounts. I'll have a quick look at the HackMD. So the question we are going to ask is, what do you see NN87 as a project? Okay, I only see, so if you only see NN99874, that's fine, yes. So make sure to check that. Yes. Okay. Make sure that you test that before you go to the exercise. And every time after this, the exercises we're going to do, when you see this text, when you see this label projects underscore name within angle brackets. You should replace this with NN 9987. So every time you see this, you should replace that. And I also mentioned that we have this VIP pass. So this is the VIP pass, how you mention the VIP pass for the course. That you usually don't do in a regular job, but today to get the pass, you need to use that. Now what I'm going to do is I'm going to show you how to run this, which means that I expect that you to not to type along, but to watch and see the mistakes I'm making. So I'm going to purposefully make some mistakes so you don't have to do in the exercise. And watch me, and then during the exercises you could type along, type on your own. Michael, are you ready to notice all the mistakes I'm going to make?
Okay.
Yes, I'm going to clear the screen. So earlier I did like this. This is to run it on the login node. Now I have to summon our SBatch. SBatch is the way how you summon this the queue manager. So we're going to tell him or tell it that piece of software. Now I want you to run it on a compute node. Then you need to specify the accounts. So I forgot the name, so I'm going to print that again. Projects. So I'll remember that. SBatch. So if you run SBatch and type example.com, so this is the first error I'm going to make. I'm going to run it as if it was a script. Then it's very important that we read what Slurm says. So it's very informative sometimes. So what Slurm says is that account specification required. You don't your payment. I cannot authorize your payment. How am I going to pay for it? So I have to specify that. So I'm going to specify account equals 9987. Okay, so I'm going to specify like this. Notice the way I type these things, because these are common errors. What happened is it thought that I'm going to refer to a file here because there's a space. So when you type account, there's no space. Your account equal signs, then this account name. Do you think this will work, Maiken, or do you see still issues?
You might have to add other things like memory usage, time, and things like that. We'll see.
Yeah, I see that you're not paying enough attention. So let's see.
You may also need to add the K at the end of the account name.
That is correct, Espen. So you have to type, yes. So you have to use this as it is. So this takes a lot of time during exercises if you try the different scenarios. So I'm going to make the errors for you so you don't have to. So then make sure that you don't follow the Saga instructions. You follow the Fox, the from instructions. Then I need to specify how long I'm going to stay on the cluster. Maiken, you told me the importance of that. So the Slurm can have an educated guess that the rest of the queue, how long they have to wait, and to determine where to place you. If there's a place where only 3 days can be allowed or 1 hour could be allowed, that Slurm has an understanding. Then I'm going to include some of the course resources here because it's a very small job. I'm going to see whether I can just use the regular queue and run it. I'm going to press enter. And then when you press enter, you'll get a job ID. So this is important. When you ask for support, if something goes wrong, if you want to refer to something, send us this job ID. This could save us a lot of time and you a lot of time, and reduce the amount of back and forth we have to go. So if a job ID is there, it's easier to help. Then after submitting, because it's a small job, it might have finished, but let's see anyway. Yeah, it's another dispatch was the first command. Second one is the SQ. You ask what are the jobs in the queue. There are none. Later on, we'll check that something while it remains in the queue. So after the job is finished, if you remember, Michael, we had one file before. Now we have two. Slum with this job ID, the job ID and a file here. So I'm going to I'm going to see what's inside that file. Slum, this file. I use the tab completion, so I don't want to type the full name. And inside that file, it says it has started this job on this compute node, and it has printed this name of the compute node here. So it's C69.2, which is a compute node, so not a login node. You don't have the login node information. Again, after that, it's give you some indication of how long the job was, what processing it took, how long it remained, and how much memory it used, and etc. etc. But this was the line that's supposed to print, and this was the output of the payload, the host name. That is the command we used. So instead of the host name, we will run the actual job in a scenario, on a real case scenario. And then again, if I run it, if I want to compare what I did before, and I will use the command grep as we learned yesterday to this script and on the slum file. So if you remember, if you see the difference, so on my script, when I run directly, it's on the login node. Now it's a compute node. Then what we do is I will try to run a slightly longer job with some more customizations. We have a lot of customizations, and there'll be a link in the HackMD very soon showing you all the slum commands from the slum instructions or things that we could mention. So here in this example job, sorry, not theme, it's nano that we're going to use. After the host name is printed, I'm going to ask the job to sleep for 60 seconds. So here, this is the thing I want to print. I'm going to ask it to 60 seconds. The reason is because the printing of host name is very fast. I couldn't show you the SQ, the job in the queue. So I'm going to ask it to sleep for 60 seconds. So I have enough time to show you that. Then I'm going to use Control X directly. Then let's say I have to save it. Yes. So now the script look like this. The addition is a 60-second the job. So because now it is a 60-second job, I want to use the VIP pass, so I don't unnecessarily disturb the others. So I'm going to include this extra arguments, partition course and reservation, HPC onboarding. So this is the VIP pass that we're going to provide. And the job is submitted. Then SQ minus U dash U $user. So now you see that it's running. Then you can say iteration every 5 seconds. Sorry, it's the wrong spellings. What was the correct spelling for that? Let's check. There is a T icon. I
don't remember. Sorry.
IT. Iterate. It's iterate, not iteration. So let's see how it's going on. So it's running. So SQ is the command that you would use to see the progress. So if it was a job that you submitted, you could monitor this later on. So now it's it went up to 1 minute, and after 1 minute it finished because we only asked around 60 seconds. Then Maiken, what happened if I submit this job and go home? Would that stop? If I log out and go home, what would happen?
Yeah, no, that's the benefit here, that you're actually not interacting with it anymore. You've sent it off and it's working on the compute node, and when it's done, and you can access the results afterwards.
Yes. So that is the best thing. The amount of resources you ask bound by it's a binding, so you don't have to worry about disturbing others or you get disturbed by others. You submit the job, the Slurm manager would take care of what necessary, where to place the job, how to run it, how to place the output. Then you submit the job and go home, and then log out and log in, or just wait for it, and then it's there. Then there are customizations that I'm going to show you. The first one is that we have to give a name. Okay, I'm sorry about that, because my muscle memory is with this VM editor, so it goes there. I'll use this nano. If you remember in this, it is said the name it has given is the file name, so it used the file name as the name. But if I want to give a specific name, I'm going to mention this here. So usually in bash, Maiken, a hash means that don't read that line, it's a comment line. But on Slurm, hash is batch means an instruction to Slurm, so it should read it. Then you could type a new name. I'll type the same thing here. You could give your name or whatever job name that will make sense, because if you submit so many jobs, it's easier for you to monitor that. Control O, Control X. So this job will look like this. So I have this extra instruction, still sleeping for 60 seconds. I'll submit the same way with the VIP pass. And when I look the SQ, I see that my new name is given as the name, not the file name. Then if you use this iteration, you have to hold on control key and control key and the C to come out of it. So let's say if I made a mistake, Maiken, then you can, without wasting resources, you can use the command scancel with the job ID to cancel it before it ends. So now it is the third command that we learned, sbatch. Actually, we learned the sinfo command in advance in the previous lesson to see the information. Sbatch is to submit, sque to see what's going on. If you did something wrong, scancel to cancel it. Let's see the outputs, Maiken. So I'm going to use this additional options on LS to sort my outputs, so I could see what was the last log that I had. Let's view this 8 7. So here, Maiken, do you notice the place that I should focus on? Which line that I should?
Yeah, well, maybe you're wanting to indicate that there was an error there and the information.
Correct. So this job was cancelled. So that's what the output was. It was not this job is running on something. So it was cancelled. Then Maiken, before we so what I'm planning to do is to give more time on these exercises, so they'll have more time to practice. The last thing I'm going to show, usually so our exercises would start at 11, but let's see whether we can start it before that. The resources you ask, let's say if you want to ask for 1 hour and you submit a job that takes 3 days, what would happen, Maiken?
It would fail, and you would see an error in your Slurm script that it would went out of time.
apologies, I opened the wrong editor, but I'm going to go through this anyway. Let's move more commands inside this batch script as we did before. Earlier, I mentioned these things in the terminal, like when I submit this. So these things, Michael, when it's easier because you don't have to type everything all the time. If we can, sorry for scrolling too fast. Let's move on. Where did I submit this? The course. Again, apologies for moving back and forth. So these things also you can include this as instructions inside the file.
Yeah,
Yes.
I don't remember if I heard you mention it, but typically yesterday we said that we use the hash symbol for comments in the script. That's completely correct, except for the first line for this bin bash and for the sbatch. So the sbatch command needs to have this hash symbol, and it's not a comment. Otherwise, it will be a comment. Other words.
Yes. Thank you for reminding, Mike. And maybe I mentioned it, but not just this hash, but this hash sbatch is an instruction for Slurm. So what I'm going to do is I'm going to move more things, these accounts and partition and everything inside the job script.
May I just make a comment, Sabry?
Please, Espen.
Yes, the thing is that you users might see sometimes that you see two hashes in front of sbatch. So you need to add an extra hash to comment out the command to Slurm. That's quite useful to know, especially we try to avoid people inheriting run scripts. That's why I added the link to this run script generator in the discussion notes. But sometimes you do, and then you will find sometimes a double hash instead in front of the sbatch. That basically means that the comment or the command to Slurm is inactive. So you need to remove one of the hashes to make it active.
Thank you. Thank you very much for that. That's a very important point. So here I'm showing you more ways to mention this. You can have sbatch and you can have these accounts in one line, or you could have multiple instructions in the same line starting with sbatch. As Espen very wisely pointed out, let's say you use this command, you use the same job script tomorrow, like after the course to test your own job, and you wanted to comment it out, you should use 2 hashes. That means then this course partition reservation would not be counted. So if you want to comment out an sbatch, you should use 2 hashes. So again, let's make a mistake and see, just to make sure that we don't have to do it again. So do you remember the mistake in this, Michael? You see an error? You don't see an error, okay. But let's ask sbatch. Submission failed, invalid account. Can you notice the error? So there's a K at the end.
Oh yeah, sorry.
So,
yes, I was multitasking, answering questions on HackMD.
Thank you. So then at the same time, what I'm going to do is I'm going to show you that resource binding scenario. I'm going to make this sleep for 5 minutes, but I'm going to ask only 1 minute as runtime. So again, for the discussion, Michael, after I submit this, I will submit this and then I will ask it to iterate every 10 seconds, maybe 15. Oh yeah, 10 is okay. So in a queue, if your job is taking three days and if you ask for 1 hour, what is the replication, Michael?
Well, the job will fail.
Yes, job will fail, and it's fair, isn't it? Because you ask for less time and the slum did all the calculations according to what you asked, then you decide to stay longer, then you have to be thrown out. So it's like, you go to a restaurant and you order dinner and you start, decide to stay on the table or spend the night. That's not allowed. But how do you know that how much time you ask, Maiken? Is that something that you could do is that something very obvious?
That's tricky. So that requires that you have maybe run it before and you know how long it takes, or you've run a smaller sample and then you can calculate how long it'll run to the full program. So yeah, this is something you as user have to figure out and try to estimate. And maybe you've put shorter time and then it fails, and then you'll just have to increase it next time you try to run and hopefully get it right.
Yes. And at the same time, if you don't know exactly how much time you need, say it's 1 hour, 2 hours, that's the job would take. So you ask about a week, because just in case you think, you could ask 1 week, so your job will not fail. So when you ask that, Slum need to calculate and place you in a proper place. So you have to stay longer in the queue. So what happens is the jobs that need shorter period of time would be prioritized because they could finish quicker. And Slum thinks, you have to decide, you're going to stay 1 week anyway. So staying 1 hour more in the queue is not a big difference. But if somebody wants a 10-minute job, staying in one hour in the queue is significant. So that's part of the quality of service that Slum has. So it decides where to place. If you ask a lot of time than you need, you have to wait more. And if you ask a lot of time, you'll be charged for that period. But if your job ends before that, you'll be reimbursed. So if you submit a job, that amount you would ask to be reserved. So Slum is generous in that case. If your job finishes, it will be reimbursed. But you have to find the optimal amount of time that you have to ask.